Yo guys, in this video we're about to do the calculus exam June 2024. I'm gonna do a bit of explanations here and there, but I'll focus on trying to get all the questions done in a short amount of time because I know you guys don't want to watch long videos. Okay, so the first question 1 A, it says we should differentiate y equals e to the 2x tan x. Okay, to differentiate this, we first have to see that this is one function, this is a second function. These are two functions. Since we have two functions that are multiplied with each other, we have to use product rule. So how you apply product rule is you say dy on dx equals, you start with the first function, e to the 2x, and multiply with the derivative of the second, tan x. And then to that you add the second function, tan x, with the derivative of the first function, e to the 2x. Okay, so this is our product rule. First function, second function, derivatives. Now the next thing we do is we keep this the same, e to the 2x, and you differentiate this. The derivative of tan x is sec squared x. Right, sec squared x. If you don't know that, you can try to do it using like quotient rule. Change tan to sine over cos and then use quotient rule to find it, but you'll find sec squared x. Tan x, we keep that the same, and we differentiate that guy. So this guy, he's two functions because there's e to some power. That's the first function, e to a power, and then the second function is 2x, and it's inside of the first function. That means we have to use chain rule. Chain rule says we have to differentiate the outside function first. So the outside function, since it's e to some power, right, e to a power, the derivative of e to a power is still e to a power. So we still have e to the 2x, the same power. Now let's differentiate the inside function, 2x. What's the derivative of 2x? It's 2. Okay, so the question says do not simplify your answer, or you do not need to simplify your answer. So you can leave your answer like this and go to the next question. That's B. So B says you should differentiate y equals sine square root x over 2 to the x. Okay, here there's a division line, which means we have to use the quotient rule. How we apply the quotient rule is, so dy on dx. How I like to do the quotient rule is I just draw a division line and then I just square the thing at the bottom, right? That said, you always do that. Draw a division line, square the thing at the bottom, and then you take the thing and also put it at the first, here basically, 2x. So draw a division line, take the thing, square it, take the thing, put it there. Now you can continue with your quotient rule. You got d on dx of the second function, which is sine square root of x, minus sine square root of x d on dx of 2 to the x. If you still can't apply quotient rule, I have videos on quotient rule, and yeah, you can ask on WhatsApp and I send the link because I don't want to spend too much time editing the video and editing it into like, basically ask on WhatsApp if you need that video. So you have 2 to the x, that doesn't change. Let's differentiate this guy. So the derivative of sine root x, we have two functions once again here. The outside function is sine of something, right? The outside function is sine something. What's the derivative of sine of something? It's cos of that thing. So cos root x, sorry. Now we have an inside function, which is square root of x. We need to find the derivative for square root of x. So let me do that here. So the derivative of the square root of x, d on dx for root x, you first have to write root x as x to the half, right? And then you just differentiate how you would normally differentiate. So that would be, take this to the front, you have a half x to the power of a half minus 1, which is going to give you negative a half, right? So they said don't simplify. So you can simplify this, but just let's write it like this so that we save ourselves some time. Half x to the negative a half. That's what we found there as the derivative of this inside thing. Okay, let's continue. Minus sine root x. Now we have 2 to the x. For 2 to the x, there's a couple of ways you can explain it, but I think the shortest way or the fastest way I can tell you guys or show you guys how to do it is, there is a document I sent on differentiation. I think it's chapter 3 problems bank. If you scroll down to the end of that document, I sent it on the group. You scroll down to the end of that document, you're gonna find a cheat sheet for chapter 3. It has the derivatives of different things. So there, you also find that the derivative of a to the x is equal to a to the x ln a. You also find that there, which means where a is like any number, let's say an element of real numbers for now, because you guys are doing real numbers. Okay, so if a is an element of real numbers, the derivative of a to the x, so any number to a power, so 1 to the x, 3 to the x, 4 to the x, anything, it's going to be equal to this. This is the derivative of it. You're going to take the same thing and then multiply by ln a. There's a longer way to explain it. Perhaps I might give it one day, but for the purpose of exams, you don't need to know that much. So let's try to see the derivative of this guy. So it has to be the same thing, 2 to the x times ln of the base, ln 2. That's how we find the derivative of that. Then we draw a long division line and bring back our 2 to the x all squared. No need to simplify. The question asked you to, well, told you you don't need to simplify, so you can leave your answer there. Okay, so that's question 1. Let's go to question 2. Question 2 says y sine x plus x e to the y equals 5. Okay, so they say we should find dy on dx if we have this. So that's implicit differentiation. For implicit differentiation, you want to differentiate the right-hand side and the left-hand side. Okay, why is it implicit differentiation? Because we have a y on the exponent there, and we have a y here. You can't make y the subject of the formula here. You can try, but you can't. Even if you could, it would take you a long time, and hence it wouldn't be worth the work. So we're going to use implicit differentiation. We're going to differentiate the right-hand side and the left-hand side, and then we're going to make dy on dx our subject. So d on dx of this side, y sine x plus x e to the y equals d on dx of 5. Okay, just differentiating both sides. Let's start here. The differentiation sign can come here and there. So let's distribute it. You get d on dx of y sine x plus d on dx of x e to the y equals this side. The derivative of any constant is 0. Let's come here now. These are two functions. There's y and there's sine x. How do we differentiate this? We use product rule like we use on the other functions. So if we're using product rule says d duv on dx equals udv on dx plus v du on dx. Okay, this is product rule. Just a reminder, sorry if you already know it. Product rule. Okay, so let's apply our product rule on that. So this is our first function, so let's just write it as it is. We got y, and then the derivative of the second function, derivative of sine x. What's the derivative of sine x? It's cos x. Cos x plus, still here, now we start with sine x. Start with the second function. Now the derivative of the first function, derivative of y. We can only write the derivative of y as dy on dx. Okay, so this is what we have for this so far. Let's go to this side. This side, still it's x times e to the y, which means it's also product rule because two functions are multiplying each other. So to apply product rule there, we first have an x times the derivative of e to the y. And then we have an e to the y times the derivative of x. But the derivative of x is just 1. So you can just write 1 for that. I'm writing this like this because it's going to be, I want to explain it properly for anyone who needs some more. Okay, so we have this, we have y cos x plus sine x dy on dx, dy on dx plus x. So this is the part I wanted to show you guys. Derivative of e to the y. We have two functions here. It's almost the same as that e to the 2x, because 2x was a function and e to the something was a function. So to differentiate this, the derivative of e to some power is still e to some power. We're using chain rule. Then the derivative of the exponent is dy on dx. Okay, because the exponent is also a function. So you differentiate the outside function, you get this. You differentiate y with respect to x, you get this. Plus e to the y equals 0, because this one just doesn't matter. Now what we do is, we take anything that doesn't have a dy on dx to the other side, right-hand side, because we want to end up with dy on dx this side only. So we have sine x dy on dx plus x e to the y dy on dx equals negative e to the y negative y cos x. Okay, these guys went to the other side, this guy and that guy. Now let's take out dy on dx as a common factor. Dy on dx equal to sine x plus x e to the y equals minus e to the y minus y cos ex. Sorry. Now we just, I hope you guys have been following, but now we just divide by this guy. So maybe it doesn't look straightforward as to what I'm doing. Like it's obvious what I'm doing, but what I'm trying to do. So what I try to do first is I try differentiating both sides. That's the first thing. The next thing is to just make your dy on dx your subject of the formula. So you differentiate both sides and then you make dy on dx your subject of the formula. That's what I'm trying to do here. So when we divide by this guy on both sides, we have dy on dx is negative e to the y minus y cos x all over sine x plus x e to the y. Okay, so this is what we have. That's your dy on dx. If I made any mistakes, you guys feel free to point it out, but the point is for you guys to see the principles, not exactly to see the answer, in my opinion. So like, don't fight me too much. Thank you. I know you guys will listen. Okay, let's go to the next question. That was question 2, and that was the only question in question 2. Now we're going to question 3. Question 3, it has an A, and the A is saying we should find the integral of 1 over 9x squared plus 6x plus 2 dx. Okay, so to find this integral, damn, okay, only 15 minutes. That means I'm going good on time. Okay, to find this integral, anytime you find 1 over some polynomial, a quadratic polynomial, yeah, let me say that. Anytime you find 1 over a quadratic polynomial, so this is quadratic because the highest exponent is 2. Anytime you find that, you first complete the square, then you make sure you have a 1 on the other side. I'm going to show you how you do that, but complete the square and then make sure you have a 1 on the other side. And then you're going to see what integral that is. So let's first try to complete the square. So if we try to complete the square here, we're looking for the integral of 1 over, got a dx there. Let's first take out the 9 as a common factor. It's not a common factor, but let's take it out so that we don't have a coefficient for x squared. 9 into x squared, right? If you take out a 9, you're not going to have a 9 there anymore. Plus, if you take out a 9, this is going to be 6 over 9. Because you're basically dividing by 9 on the other terms. X. Plus, you take out a 9 from a 2, you get a 2 over 9. Okay. That's integral of 1 over 9 into, you got x squared, plus the 6 over 9 can be written as 2 over 3, yeah, x, plus 2 over 9 dx. Okay, so right now we just took out the 9 as a common factor. That's all we've just done. Next thing is, if we want to complete the square, we look for half the coefficient of this guy. So that's going to be 2 over 3 times a half, right? Half the coefficient. And then we have to square whatever answer we have. We get, that's how we complete the square. Half the coefficient of the middle term squared. So these 2's are going to cancel. We're going to have 1 over 3 all squared, which is going to be 1 over 9. So that's what we have to add and subtract here to have our square completed. Let's do that. We have integral of 1 over 9 into x squared plus 2 over 3x. For anyone who enjoys maths and stuff, you can just separate this to be 1 over 9 plus 1 over 9 and it's still gonna work. But for anyone who wants to just get the job done, let's do it the right way. So don't stress about that if you don't understand it. Plus 1 over 9 minus 1 over 9, okay? Because this 1 over 9 is gonna complete the square for this guy, but we have to subtract it so that this is still equal to what we had there. Plus 2 over 9 dx. Okay, so we're just dealing with the denominator so far. Let's go to the next step. Integral of 1 over 9 into x squared plus 2 over 3x plus 1 over 9. Okay, next step, we're going to factorize this. Right now, let's deal with these guys. Denominators are the same. The numerators are not the same. So 2 minus a 1, because this one is negative and this one is positive. So 2 minus 1 is 1. That means we have 1 over 9 dx. That's why I said if you enjoy this stuff, you can write this as 1 over 9 plus 1 over 9. But yeah, let's continue this way. Integral of 1 over 9 into, let's factorize this guy now. If we factorize this guy, we completed the square, so it has to factorize to x plus, what's the square root of this guy? It's 1 over 3 all squared. It has to factorize to this because that's what we're trying to do when we completed the square. So you take this, you take 1 of this guy, and then you take a square root of this guy, and it gives you that, plus 1 over 9 dx. So this is just completing the square. If you don't understand that, you have to search like a video on completing the square and you'll understand why you had to do this. Next, and this is integration. It's not even like anything else like integration. So you need to learn this stuff. Eh? It's tough, but you came to it, so you must stand in the light and stuff. Okay, let's multiply this 9 into the inside. You get 9 into x plus 1 over 3 all squared plus 1, because when you multiply the 9 with this, it gives you a 1. Now, back to what I said when this was starting off. I was telling you guys what you should do when you have a quadratic in the denominator. What you should do when you have a quadratic in the denominator is to complete the square. We just did that. We completed the square. This was when we were done completing the square. Then the next step is to make sure you have a 1. You see, we had a 1 over 9. So we multiplied with a 9 into the inside, and we ended up with a 1. Those are the first things you do when you want to deal with anything that has a 1 over a quadratic. In your first year, maybe going forward it might change, but in your first year, that's going to keep you safe. If I didn't have a 1 here after multiplying with a 9, maybe I had a 3 or 4 or 5, 7, whatever. Let's say I have a 9. Let's say I have a 7. Okay, if I had a 7, I would then have to divide by the 7 here, divide by the 7 here, and divide by the 7 on the numerator. So if I divide by the 7 on the denominator and divide by 7 on the numerator, that means the value of my whole expression has not changed. So if I would have done that, I would have ended up with a 1 here because I divided by a 7 and I had a 7. Then you would be able to see which identity to apply. But in this case, we are lucky because it gave us a 1. So you're going to see which one it is. But first, you see how this is squared. And 9 is also something squared. I'm going to take the 9 inside. I'm going to write it as 1 over, that's going to be 3, right? 3, let me just multiply it's going to be 3 into x plus 1 over 3 all squared, right? Because if you take the squared here, it gives you the 9. Then take a squared here, it gives you what you already had, plus 1. I didn't imagine this was going to take a whole page. Anyways, integral of 1 over, let's multiply the 3 into the brackets as well, just because it's fun. 3x plus 1 all squared plus 1. There's probably an easier way to do this. Probably. But can you complete the square with a coefficient? If you guys know how to do that, you can, maybe you would have been able to do that from here. If you can complete the square while you have a coefficient here. If you do that, you would have had probably the same answer. Okay, so now what we have is 1 over something squared plus 1. That clicks because that's, remember, the derivative of, is it, yeah, arctan x is equal to 1 over 1 plus x squared. You have a 1, you have an x squared, something squared. So this is not just arctan, it's arctan of something, of 3x plus 1. But I'm going to show you how you do that. So basically you had integral of 1 over 3x plus 1 squared plus 1 dx. What we're going to do is, since we notice that this is something squared, let's just say let u equals 3x plus 1. Okay, maybe that's not going to be as fun as I thought. Is it? Is it going to be fun? du on dx equals 3x. Dx equals u over 3 And yeah, let's try it. Du on dx equals 3x equals 3, sorry, my bad, equals 3, because that's the derivative. And then dx equals du over 3, right? Okay, this is u substitution. I actually didn't think we were gonna need it, but it seems like we are. U substitution. Yeah, we are going to need it actually. So we're using u substitution. You let this be u, so that gives you the identity for the derivative of arctan. So basically now what we have is integral of 1 over u squared plus 1 dx. We found out that dx was du over 3. So that's du over 3. The 1 over 3 is a constant, so you can take it out of the integral sign. You have a 1 over 3 integral of 1 over, let's just write this as 1 plus u squared now, du. Perfect. This is exactly the identity for arctan. If you don't know the identities also, again, go to the problems bank that I sent on the group. Scroll to the very end. There's a cheat sheet. That cheat sheet has your derivatives, your integrals that you need. That's chapter 4, because I sent a chapter 3.1 and I sent a chapter 4.1, so you guys have both. Right, now you have a 1 over 3 integral of this. This is exactly the identity for arc10, but we're gonna say u, since our variable is u. 1 over 3 arc10. What is u? U is 3x plus 1. So we bring back the 3x plus 1. So basically your answer is arc10 of 3x plus 1 all over 3. Okay, that's your answer. Plus C. Ish. Remember your thingy. Don't be like me on that. Plus C. Always add your integration factor if you the integration constant or integration constant of integration. Yes. Okay, let's check if we can get this if we try to differentiate this, because you should be able to move forward and backwards in integration and differentiation. If we were to differentiate this, you would have to use chain rule. So the inside function is 3x plus 1. The derivative of that is just 3. So the 3's would cancel out. And then you'd have to find the derivative of the outside function, which is just arc10. Arc10 of this would be 1 over 1 plus 3x plus 1 all squared. I just apply the identity for arc10. So if you don't know that what the identity is, again, problems bank, scroll to the end, cheat sheet, you see the identities. Okay, so let's check. It's 1 over 1 plus 3x plus 1 all squared. 1 over 1 plus 3x plus 1 all squared. So that means our answer is correct. Integration is new to you guys, so you need to pay a lot of attention to it. Differentiation, you can sort of get away with some stuff, but integration, you need to do a lot more practice. Okay, B. This is still question 2. Now we're doing B, 5 marks. It says integrate this one. Negative x plus 1 over x plus 1, x plus 2 dx. And the hint is decompose into partial fractions. I'm not sure if the marking police guys will be mad, but what I'm gonna do is I'm gonna write this as negative x plus 1 over x plus 1, x plus 2. I'm just gonna deal with this first, decomposing it, and then I'm gonna come back to writing the integral sign and the dx, because it's annoying to keep writing it over and over again. Don't do that You don't do that. I can do that because I'm a second year. Okay, so if we decompose into partial fractions, we're gonna have a over x plus 1 plus b over x plus 2, right? And then if we cross those, we get a into x plus 2 plus b into x plus 1. Again, you need to make sure you understand your block 1 work because it will be required sometimes, especially partial fractions. They like bringing out this question, so make sure you at least know how to do at least the basic ones at least. Okay, now our x here is negative x. The x term here also has to be negative x. So that means ax plus bx must be equal to negative x. Okay, because this is going to be ax, that's going to be bx. Now that's a plus b, x equals negative x. So a plus b, coefficient of x, must be equal to the coefficient of x that side. That's our first equation. Now let's make a our subject. Maybe a equals minus b minus 1. Maybe we can say this is our second equation. That was just dealing with the x's. Now let's deal with the constants. This is going to be 2a plus b. Okay, 2a plus b. Again, guys, as I said on the previous video, if I'm moving too quickly, please just let me know on WhatsApp, and so that like on the next video I can like slow down and explain things properly. A is minus b minus 1. So 2 into minus b minus 1 plus b is equal to 1. So I just substituted 2, equation 2. This multiplying into that gives us negative 2b. This multiplying into that gives us minus 2 plus b equals 1. B minus 2b, that's minus b, equals, let's take this 2 to the other side. That gives us a 3, because that's positive 2 this side, plus 1, that's a 3. Therefore, b is equal to negative 3. If you have a shorter way of doing, you can use that way. You can use another way if you know another way of approaching like partial fractions, especially if it's shorter than mine. A is minus b minus 1. Okay, now we have a as this is positive 3. 3 minus 1 is 2, so that's 2. Now let's write our thing as partial fractions. We have negative x plus 1 over x plus 1, x plus 2 is equal to, how are we going to deal with a 3? Okay. A is 2 over x plus 1 plus b is, oh, never mind. B is negative 3 over x plus 2. Okay, this is what we have. Therefore, since we are looking for the integral of negative x plus 1 over x plus 1, okay, all of these steps are just partial fractions. Dx from first block. If we're looking for the integral of this guy, it must be equal to the integral of this guy because these guys are the same. So that's going to be integral of 2 over x plus 2. What I'm going to do is I could write integral here and then put these in brackets and say dx. But since the integral sign can be distributed, I'm going to distribute it straight up to these guys. So I'm going to have an integral of this guy plus integral of this guy. you can't do that. Dx plus integral of -3 over x plus 2 dx. Okay, that's what we have. Let's take out the 2 from the integral sign. We got 2 integral of 1 over x plus 2 dx plus, actually I should have said negative, but fine, integral of 1 over, wait, no, this is a 1, sorry. You see, this is this guy. This is a 1. X plus 2 dx. Okay, the integral that is like this, 1 over something, is ln, ln of something. Because ln is, again, this is 1. Because ln is like this. So if I have the derivative of ln x plus 9, right? Derivative of ln x plus 9 is going to be 1 over x plus 9 times the derivative of the inside function. The inside function, the derivative of that here is just 1, because the derivative of x plus 9 is 1. So I would have multiplied by 1, which is still 1 over x plus 9. Okay? That's what happens if the derivative of the inside is just 1. So now we're trying to reverse engineer that. Since we are looking for the integral, we already have a 1 over something. 1 over x plus 1, 1 over x plus 2. That means that must have come from ln something inside. Right? Ln something inside. So let's apply that. It's integral of something. You guys write the thing, I forgot the thing. 2 integral of 1 over x plus 1 dx minus 3 into, 3 1 over x plus 2 dx. Okay, you guys write that real thing, dx. I'm a lazy guy. So here we have 2. This has to be ln x. How about ln x plus 1? ln x plus 1. And that's in brackets. I'm not sure if they require you guys to put an absolute value on these or not, but let's assume they don't. Minus 3. If they do, your lecturer has probably told you guys in class, so you're good. Okay, this is the integral plus c. Okay, this is the integral of the original guy, which I forgot. Let's test if this integral holds up if we try to reverse. Derivative of ln x, because the 2 is just going to be a 2, so the 2 is already correct. The 3 is already correct. We just need to check if this gives us that. The derivative of this guy is going to be 1 over the thing that is inside the brackets, x plus 1, and then multiplied by the derivative of the inside. Derivative of the inside is just 1. So this is correct. By the same logic, this is also going to be correct. Let's go to the next question. That was 5 marks. So now we go to question 4. Question 4. Question 4 is a Riemann sum stuff thingies. I forget that equation, so let me go get it real quick. Alright, I got it. So this is the equation for the area if you're using the Riemann sum. I haven't even read the question and I'm already there. In the question they gave us, okay, actually I should be doing that. This is what they gave us on the question, and they said this is a fancy R, and the equation is y equals x squared minus x cubed. That's y, that's x. and then they shaded this place in. Oh dang, artist. And the diagram below shows are bounded by that. Banban, calculate the area, blah blah blah, use formula. Okay, so basically they gave you guys this, and they say find the area of this inside using the Riemann sum and the hints that they gave you. To do that, first you need to know the bounds, right? Anytime you're trying to find an area, you need the bounds. You need the bounds. So here it looks like it's 0, but we have to prove that it's 0. To find the bounds, in this case, since it's bounded by like the intercept here and the intercept there, we just need to find the intercepts of this equation, the x-intercepts. For x-intercepts, let y equals 0. Beautiful handwriting. If y is equal to 0, you got x squared minus x cubed equals 0. Now take out x as a common factor, x squared. You got 1 minus x equals 0. This just gives you a 0, but you see how it's squared? Actually, let me explain that part to you guys. You don't have to know it. X equals 0, and then you have x equals 1 this side. You don't have to know that thing that I said I'm not going to explain to you. It's just going to waste time. 0. Okay, so your intercepts are at x equals 0 and x equals 1. So that's x equals 1, that's x equals 0. You've confirmed them. Now, actually, I'm really tempted to say this thing. So you see how this is squared, and but it gives you one answer. That's to confirm that it's essentially an intercept from 2 directions. You see how this one is an intercept from a line that only has like one direction, it's going this way. But this one is an intercept at like a turning point. So it's an intercept for this gradient and an intercept for this sort of direction. So it's an intercept twice, that's why it's like this. But it's really not going to help you with anything you're going to do this year. It's just a fun fact. Right, these are our bounds. Let's get back to the equation for the Riemann sum. This is the equation. B is the upper bound, A is the lower bound, B upper bound, A lower bound. N is approaching infinity, and it's sort of like a constant that's like infinity in a sense, so we don't have to worry about that, about finding it. So we also already know I is your index, it changes, so you don't have to worry about that. N, again, is sort of like a constant in a sense, and it's approaching infinity. Therefore, basically, you have everything you need now, because you also have F. It's the equation of the thing that is drawn. So you have everything you need to start applying your Riemann sum. Let's apply it. So it says area equals, where is it? Limit as n approaches infinity of b minus a over n, sum up to n from I equals 1 of f of a plus I, b minus a over n. Okay, this is what you have. Limit as n approaches infinity. Our b is our upper bound. Your upper bound is x equals 1. So that's 1 minus what? Minus 0, because the lower bound is 0. So you don't have to really put that in. Sum up to n from I equals 1 of f. F, we know what f is. It's x squared minus x cubed. So let's just write that. We got x squared minus f cubed, but actually, let's do it like this. First, let's write it as f like this. What's our a? It's 0, so no need to write that. And then you got I. B is 1. Essentially, this is going to be the same as this. So it's just 1 over n. Right? which is basically I over n. Now let's substitute the function. We got limit as n approaches infinity of 1 over n, sum up to n from I equals 1, f. What's our f? Our f is x squared minus x cubed. What's our x in this case? It's I over n. X in this case, I over n. Okay, that's what we have now. Okay, so we're looking for the limit as n approaches infinity of 1 over n. What I'm going to do is I'm going to distribute the summation sign between these two guys. This actually should be written like this. I'm going to distribute the summation sign between those two guys. So I'm going to have sum up to n from I equals 1 of something minus sum up to n from I equals 1 of something else. Okay. Now what's the first thing? The first thing is is it squared? Was it really squared? Or was it? I think it was squared. Okay, so that's I squared over n squared, right? That's I cubed over n cubed. Now we got limit as n approaches infinity of 1 over n. Now I'm going to distribute the 1 over n as well. Like I'm going to multiply it into here and multiply it into there. So we got sum n, we got I squared over n squared, minus 1 over n, sum to n from I equals 1 of I cubed by n cubed. Okay, this is where a bit of understanding is required. But then if you hold it here, you can do it forever. N is the upper bound. I know I said n is approaching infinity. That's what this is saying. But essentially, n is the upper bound. It's the upper limit of the function. So the upper bound has to be a constant. It's approaching infinity, true. If it's approaching infinity, that means it's a very large constant. But is it a constant? Yes, it's a constant. So because n is a constant, that means n squared is a constant. And n cubed is a constant. And you can take constants out of the summation sign. I should have put it I equals 1 here. You can take constants out of the summation sign. Oh, I should have these. So we're going to take this n squared out. And if you take it out, since it's 1 over n squared, it's going to make this n cubed. So we have limit as n approaches infinity of 1 over n cubed sum of I squared minus, this is going to be 1 over n to the 4th by the same logic. 1 over n to the 4th sum of I cubed. Okay, this is what we have. This is where your hint comes in, because now you just have I squared. Now you have I cubed. And that's what we've been trying to make here. That's what we've been trying to get this question to be. That was the whole point of me distributing the summation sign. That was the whole point of me taking out the n squared since it's a constant. It's so that we can apply our hint. The hint. Okay, let me show you on my laptop the hint. This was your hint. It's not clear. Hope it's clear right now, but if it's not, I sent the question paper on the WhatsApp group 2024, so just look at the question paper there. This was your hint. So j squared, we have an equation that has a I squared here. J cubed, we have an I cubed. So we can just apply these on these equations of ours. Okay, this is supposed to be up to n, I equals 1, up to n, I equals 1. Video is longer than I expected. And we've not even done what was on the other side. It was limit as n approaches infinity of 1 over n cubed sum of I squared minus 1 over n to the 4th sum of I cubed. Right. Yeah, just the bounds now. Up to n, I equals 1, I equals 1. Okay, so now this guy, he is going to be, we're going to substitute the equation for I squared. That's from algebra. But they gave you the hint, so good. Limit as n approaches infinity of 1 over n cubed. The equation they gave us said n into n plus 1 into 2n plus 1 all over 6 minus 1 over n to the 4th. Now we're coming to this side. I cubed has an n squared into n plus 1 or squared all over 4. Okay, this is what we have. We had limit as n approaches infinity. Now we're trying to evaluate the limit. To evaluate the limit, here I'm going to try to show that a lot of things are 0, and then we're going to end up with simpler stuff. So on the top, let's distribute, let's multiply that out. We're going to have n into n times 2n, you got 2n squared, n times 1, you got, okay, yeah, 2, you got n, you got 2n, you got 1. This is high school work, so just multiplying it out. Hope you guys understand. If you don't, you can search a video on like multiplying out polynomials. So this, I just put the n cubed here. Now let's go here. We got n squared into square the first term, n squared, multiply the first term by the second term, and then multiply your answer by 2. That's going to give us 2n. Square the last term, get 1. You guys are going to do binomial theorem if you haven't done it yet, and that's where you're going to deal with such stuff. 4n to the 4th. Okay, we're still trying to evaluate the limit now. So I multiplied out. I'm still going to multiply with... Yeah, no need to multiply with this guy. We can just cancel out with the denominator. Limit as n approaches infinity of... This n is going to cancel one n from the denominator, and you're going to end up with 2 to the n plus... This is 3n plus 1. Okay. Do you agree with me that on the denominator we'd have 6n squared now? So I'm going to divide that 6n squared to come to this guy, to come to that guy, and to come to the last guy. I'm going to have 6n squared. Wait, what is happening here? n squared. 6n squared, 6n squared. Minus, let's come to that guy. Same thing. The n squared is going to cancel 2 n's here, and you're going to end up with an n squared only. That's n squared plus 2n plus 1 over 4n squared, 4n squared, or 4n squared. Limit as n approaches infinity. Right, why was I doing this? Because I want to show you guys that some of these terms turn to 0. They become 0 as n approaches infinity. Let's start with the first one. The first one, the n's are going to cancel. It's both n squared. So it's 2 over 6, which is 1 over 3. The second one is 1 over 2n, right? It's going to be 1 over 2n. And the third one is going to be 1 over 6n squared minus, let's come here, the ends cancel, 1 over 4, distribute the negative sign. This becomes 1 over 2, right? And the n at the bottom stays. The last one becomes 1 over 4 and squared, it doesn't change. Okay, no need to write the limit anymore. Let's find the limit of all of these now. The limit of the constants, the 1 over 3 and the 1 over 4, is going to be 1 over 3, 1 over 4. They want to change. Let's look at the other numbers aside from the constants. This guy, as n approaches infinity, the denominator approaches infinity. 1 over something approaching infinity, that's 0. Because think about it. If you grow the denominator of a number, you make the number smaller. So this gets so small that it becomes 0. So that's 0. This guy, by the same logic, you're growing only the denominator, so it should be 0. This guy is exactly the same as this guy. So if you like, you would have not even evaluated the limit for this guy, would have subtracted them and had a 0 from them. And then you'd get a 0 from this guy. And then from that guy, guess what? 0. So our final answer is basically 1 over 3 minus 1 over 4. We get 4 minus 3 over 12, right? This multiplied by that, this multiplied by that. And then multiply the 2, give you 12. That's 1 over 12. That's our final answer for this question. What was the question again? The area. Does it make sense? Let's check. This is from 0 up to 1. And the maximum of the function, I don't want to go through the trouble of finding that. From 0 up to 1. So the area definitely has to be sort of around 1 or less than 1. Something around those lines. So I'm guessing 1 over 12 is a reasonable answer. I don't want to spend too much time trying to explain that, so let's go to the next question. The next question is question 5. It says you need to find the area of the curves, okay? Find the area enclosed by the curves y equals e to the x and y equals x squared minus 1. That is enclosed by these lines as well. X equals minus 1 and x equals 1. Okay, the lines thing, it's like, it's the bounds, ne? This is the lower bound, this is the upper bound. So essentially, let's draw some, I shouldn't have drawn it like that. That's fine. Let's draw some random graph. Not drawing this, actually we can't draw these because they are sort of easy. Okay, let's draw these graphs. -1, -1. That's our lower bound. And then we have a 1. That's our upper bound. You can even draw it as a straight line. That's our y-axis. That's our x-axis. This is waist to space. That's our 0. That's our 1. Okay, let's see now. The first function is an exponential function. Y equals e to the x. Y equals e to the x. Y equals e to the x is something like this. And then it grows. Y equals e to the x. Let's check what the value of the exponential function is at 1. X equals 1. X equals 1, it's equal to e. And e is something close to 3. So we got e. At -1, it's 1 over e. 1 over e is something close to 1 over 3. So we have something like that for the exponential function. At x equals 0, it's equal to 1. You don't have to draw it out. I'm just drawing it out for fun, realistically. You don't this is a completely useless step for answering this question. And I don't think they're going to give you any marks for it. I guess for explanation purposes, I'm going to show you guys. And then the other function is x squared minus 1. X squared minus 1. x squared minus 1 is a positive parabola, and it's been shifted 1 unit downwards, right? So it meets the x-axis, the y-axis at y equals -1, and it's a parabola. The x-intercepts should be at x equals 1 and x equals -1, I think. So it's something like this. The area they want you to find, the question says, find the area enclosed by the curves, this and this. So the area they want you to find is the area enclosed by the curves. The curves enclose this area. Okay, so that's the area you have to find. Now check it out. This function is on top of the other one. So at any point, if I want to find basically the height of a block that can be here and the height of another block, because if you add all the blocks that make up this entire shape, if you add all of the blocks up, that's going to give you the area. But if I want to find the height of one block, I have to take e to the x. That's going to be the top coordinate, because that's the top function. It's e to the x. And then I have to subtract to the top bottom thingy. I have to subtract x squared minus 1, because that's going to be the bottom function. X squared minus 1. Okay. Which means essentially our thing is going to be like this. If you want the area, you just find the definite integral. That's what the area is. That's how you find the area. So the definite integral, the area, is going to be equal to the definite integral from the lower bound. The lower bound is -1, right? That's this, -1, to the upper bound, +1. And then you have e to the x, not 2x, x. E to the x minus x squared minus 1 dx. Okay, this is what we have. Don't be afraid to make mistakes when you practice. You see I'm making a lot of mistakes too. That means it's part of like stuff and motivation and all of that stuff. Okay, this is what we have. Let's try to open it up. We got e to the x minus x squared plus 1 dx, and we're looking for the integral of that. We've written the bounds and everything. Now that's going to be, we can distribute the integral sign to these guys and then find their integrals. What's the integral of e to the x? It's e to the x. If you don't know that, go to the problems bank, WhatsApp, scroll to the end. There's a cheat sheet that has all the integrals, all the derivatives. The chapter 4 one has the integrals, the chapter 3 one has the derivatives. What's the integral of negative x squared? It's going to be x to the 2 plus 1 over 2 plus 1. And the negative sign is just a constant, so it doesn't really thingy. Integral of 1, that's x. Then plus c. Oh shoot, this is a definite integral. No need for the plus c, my bad. Since it's a definite integral. So for a definite integral, we have this, but you also need to define the bounds. So you just do this, bring back the -1 from there, bring a 1 from there. I hope you guys are following so far. I feel like I'm going slower now than I was going when I started. So let me try to go fast again. From 1 up to that guy. You guys asked for a question paper. You didn't ask for explanations. That's why I'm doing this quickly. So if you wanted like a video on integration, then you can get a video on integration. Now, this is gonna be, we're first gonna substitute the 1 into this, and then we're gonna subtract the version of this where we substituted a -1. But first, let's evaluate this, because of this, we got e to the x plus x cubed, minus x cubed over 3 plus x minus 1. Okay, so let's do what I said. Substitute a 1 into all of this. You get e to the power of 1 minus 1 cubed over 3 plus 1, right? I substituted a 1 into every x here. This is what I get. Minus, now I'm going to substitute a negative 1. I got e to the negative 1 minus 1 cubed over 3 minus 1. Okay. See what happens now. The negative sign distributes into all of these guys. So you got a e minus 1 over e. This guy becomes a negative 1. The negative sign here makes it a positive 1. So the positive 1 times this negative sign now becomes a negative 1 again. And then the negative 1 from, so I'm looking at the numerator, so the denominator will still be divided by 3. That's a negative 1 minus negative 1 over 3. So that's minus 2 over 3. You can do this in longer steps. The question is not asking for this like simplification of numbers. So that's why I'm doing it quickly. So you guys can like watch another video for simplification or do it in your steps, which is totally fine. 1 minus, this is going to be positive 1. So that's going to turn out to be 2. Wait, that does not make sense. Oh, it does. Okay, so you can add these only, and then you can add these only, and you'll get your final answer. Right, you can search other videos for evaluating numbers like this, but the purpose of the video is to teach you how to go through the question paper, not that. So this is what we have. The answer for the question is this. I might have made a mistake somewhere, but the principles are the important part, so you guys don't have the right to fight me. Yes. Next question. Next question. Question 6. Question 6 says, given the curve f at x equals x minus 1 over x, find the x and y intercepts. Okay, that's A. Find the x and y intercepts. For the x-intercepts, I let y equals 0. So x minus 1 over x equals 0. That's going to help me find my x-intercepts. I know some of you guys get scared that if it's like this and you multiply with the x, maybe some answer is going to disappear. Not really in this case, but I'm going to show you how to get like rid of that fear. Let's say 1 over x here. Let's take 1 over x out as a common factor. You have an x squared minus 1 equals 0. Okay, so basically, because if you were to multiply in again, this would give you x. If you multiply in again, this would give you 1 over x. So I haven't lost any answers. Okay, for this factorize now 1 over x, x minus 1, x plus 1, difference of two squares. Now, if x is 1, it's going to be 0. So that's x equals 1, the first answer. If x equals minus 1, this is going to be true as well. What do we need for this to be true? For what would this have to be to give us an answer of 0? This would be 0. So let's test. You're trying to get 1 over x to be 0. If you're trying to get 1 over x to be 0, you have to have your x as infinity. Because remember, the limit as 1 over x as x approaches infinity of 1 over x, that's 0. But then this is not a limit, and infinity is not technically something you can substitute in. So this doesn't really give us an answer. That's why you can multiply with it here. So this doesn't give us an answer. These are our two answers, x equals 1 and x equals negative 1. Okay, let's go to B. Oh, sorry, no, it's still a, but like the y-intercepts now, which don't exist, I think. Okay, y-intercepts, you have to let your x equal 0. This is your function. So if you let your x equal 0, like f at f at 0 equals 0 minus 1 over 0, but you can't divide by 0. Therefore, no defined y-intercept. Okay, let's go on to B. We don't have y-intercepts. These are x-intercepts. For the y-intercept, for the next question, it says find all vertical, I'm gonna say V, horizontal, I'm gonna say H, and oblique asymptotes, I'm gonna say O. I wanna say OB, sounds cooler. I wanna say OB. It says find all vertical, horizontal, or oblique asymptotes of this equation. Okay, so for vertical asymptotes, what are they again? It's like when like x is of certain value and it doesn't exist. So in this case, it's pretty straightforward. X minus 1 over x equals y. You see, if like this is 0, y is undefined, right? So that means x cannot be equal to 0. That's a vertical asymptote. Or you could just say, just because we have an x on the denominator, then that makes a vertical asymptote, and that's also fine. So we have a vertical asymptote at x equals 0. Because x cannot be equal to 0, that means the function doesn't touch that line. Vertical asymptote. Let's go to the horizontal one. For the horizontal asymptote, hold on a second. It's limit as like the function approaches 0 or something like that. No, limit as x approaches positive or negative infinity. Yeah. For the horizontal asymptote, you find the limit as x approaches infinity, positive or negative infinity. So let's first find the positive version. Limit as x approaches positive infinity of x minus 1 over x. This is going to get to 0. We've been talking about it. But this is going to still be x. So it's just equal to x. Which means it's equal to infinity in a sense. Right? That means you don't have horizontal asymptote. The first part means you don't. But you also have to look at the negative x. But it's going to be the same thing anyways. X approaches negative infinity. X minus 1 over x equals negative infinity, basically. So since you can't, since these are not equal to constants, they should be equal to constants for you to have horizontal asymptotes. Since these are not constants, then you don't have horizontal asymptotes. And what else? Oblique. Okay, so for oblique asymptotes, if you have some equation, you just have to sort of extract the straight line from it. Can I write it? Yeah, I can try. So let's say maybe I had x squared plus 3x plus 1 over 2x. Okay, this might backfire. I don't want to do this. Sorry. Oblique. Okay, for oblique asymptotes, basically, you find the limit as x approaches infinity. No. Yeah. And whatever that limit is equal to in terms of x, is your vertical asymptote if it's a straight line, is your oblique asymptote if it's a straight line. Okay, if it's a straight line. A straight line is something in the form y equals mx plus c. Ne? So in this case, we have x minus 1 over x. The limit as x approaches infinity is x. Ne? Since it's x is in this form because our m would be 1 and our c would be 0. That means we do have an oblique asymptote. In other cases, you would have something and you'd have to do long divisions to separate them out, and then the other guy becomes a 0 and the other guy becomes the straight line. But in this case, we already have it in that form because this is 0, this is x, so it's approaching x, and x is already a straight line. So that means our oblique asymptote is y equals x. That's our oblique asymptote. I'm really tempted to give you guys a question to do and then I skip it. It would be fun, but I won't. Use the first derivative test to find any turning point if they exist. The equation was y equals x plus 1 over x. We're trying to find the first derivative, so dy on dx equals 1, derivative of this, plus this guy. Let me write it like this for anyone who still needs help. Okay, we have that. So that the derivative of x to the negative 1 is equal to negative 1 times x to the negative 2. Ne? That's what it's equal to. And since we're trying to find turning points, you have to equate the derivative to 0. So basically you have 1 minus 1 over x squared equals 0. Is it? Oh, this is a negative. On the original question, this was a negative. That means this is a negative, and this is a positive, because negative times negative. So take 1 to the other side. You have 1 over x squared equals negative 1. You have negative x squared equals 1. You have x squared equals negative 1. You guys don't deal with imaginary numbers yet, I think. So therefore, this can't be evaluated. You can't find the answer to this because you can't find the square root of a negative number. So because of that, since let's say for now, square root of negative 1 is undefined for you guys. Therefore, no turning point, because that's what we're looking for. It's an entire, how many marks? I think four marks. So I'm guessing there's a mark for like the logic. I'm guessing, but I don't know. I don't mark you guys' papers. I'm guessing there is a mark for the logic, but maybe not. D, find the inflection points, if any. Now we gotta find the inflection points. The inflection points, since the equation was the derivative, the first derivative was this guy essentially. Dy on, this guy on dx equals 1 plus 1 over x squared. Since that's the first derivative, if we're trying to find the inflection points, we have to find the second derivative, d squared y on dx squared equals, this is going to be 0, plus, if you differentiate this, use the same rules as we did there, you're going to get negative 2 over x cubed, I think, yeah, equals 0. Now this you can't get an answer because you have like negative 2 over x cubed equals 0, and if you multiply out by the x cubed, you get negative 2 equals 0. So this is undefined. undefined. So basically you don't have inflection points. Because of that, you don't have inflection points. And find the inflection points, if any. Now it's sketching the function. Sketching it. Okay, to sketch the function, our x-intercepts were at 1 and -1. If my memory is serving me well, I'm gonna trust it. We also had an asymptote at x equals 0, I think. X equals 0. Next time I'm trying to find a plan to write it here for you guys so you can see. We have an asymptote here. We have these points, and we also have an oblique asymptote. Okay? So the oblique asymptote was y equals x. Y equals x. That was the oblique asymptote. Okay. Now the next thing for us to check is the behavior of the function as x approaches some points by looking at this. We have these points, we have these points. We don't have turning points, we don't have points of inflection. So that means our function doesn't do this, turning point. Point of inflection, our function doesn't do this, I guess, change thing. Okay, let's check the behavior of the function. The equation was y equals x plus 1 over x. As x approaches 0, because this is 0, as x approaches 0, it won't touch this asymptote. Let's check what the function is doing though. If x approaches 0, this is going to be 0. This, what is it going to be? If x approaches 0 from the positive side, you're going to have, like, it's going to keep growing, right? Because x is getting smaller and smaller. The thing, I need to show this to you guys using calculator, because it doesn't make sense if I'm just saying it. If x is approaching 0, 1 over x 0 comma, let's start with 2. Okay, if it's 2 is 0 comma 5, that's our answer. Let's get closer to 0. Let's put 1. It got smaller and it got bigger, né? It became 1. Before it was 0 comma 5, now it's 1. Let's check 0 comma 1. It got bigger again. Getting smaller and smaller and closer to 0. Add another 2 zeros there. Bigger. So as you get closer and closer to 0, it's getting very big. Your number is getting very, very big. And I think maybe we can check the calculator to give us a 0 exact, actually, because it has a limit for the number of digits it can work with. It's a challenge. Let's check. Just put a lot of zeros. A lot of zeros here. A lot. Let's check now. Okay, this has too much processing power. Okay, let's not play with that. Anyways, the point is, it's approaching 0. So from here, this side, as x approaches 0, the function approaches, approaches infinity. Oh, my bad, guys, my bad. This is negative. I'm making that mistake again. Okay, that means everything we said here, basically put a negative in front of it. That means it would have been negative infinity. So as x approaches 0, this approaches negative infinity. So the function is something like this here. Let's check that side. As x approaches infinity, this approaches infinity. Do you see that? This part of x approaches infinity. So basically the function also approaches infinity. So we have something like that. Doesn't touch the asymptote. Let's check this side. This side, as x approaches 0, right? As x approaches 0 from the negative side, we would have a negative here, which cancels that negative out, since it's from the negative side, up to 0. And then this would just get bigger and bigger. This part would get bigger and bigger. So it's approaching positive infinity, because the negative on the bottom cancels this one, and we get a positive value. So it's approaching positive infinity because it gets bigger and bigger. The function gets big until it gets to infinity. So I'm just guessing it's going to be something like this. You conclude that by checking this part. As x approaches negative infinity, the whole function becomes negative infinity. Yeah, I think that one was a bit harder to explain, mainly because I kept making this mistake of a negative sign. But if you guys don't understand, just ask me to make another video on it. I'm gonna make another video trying to explain it in more detail. Now we're on the last question, because this was a question. Now we're on the last one. Question 7. Question 7 says, let me show you guys. A particle is moving along a hyperbola y equals x over 8. As it reaches the point 4 and 2, the y coordinate is decreasing at a rate of 3 centimeters per second. The y coordinate is decreasing at a rate of 3 centimeters per second. Decreasing at a rate of 3 centimeters per second. That's a derivative, because it tells us a rate. A derivative tells us a rate of change in something. And this is changing with respect to time, because you see they say 3 centimeters per second, which means the y coordinate changes with respect to time, which means the x coordinate also changes with respect to time, right? Everything changes with respect to time. I'm not sure if you guys have covered these yet. I think they're called parametric equations, but we're gonna try to get it done with the tools that we have for now. They change with respect to time. How fast is the x coordinate changing at this instant? So we want to find out how fast is the x coordinate changing at the instant where the y coordinate is changing by -3, because it says decreasing. Decreasing gives you a sign of a negative if it's a derivative, and we have the point and it's 4 and 2. Let me show you guys what that implies. So our equation was y equals 8 over x. They both change with respect to time. What I'm gonna want you guys to do is, for the sake of this, you don't really have to do it, but I'm going to do it. I'm gonna make x the subject. X equals 8 over y. And then I'm gonna write x as x of t equals 8 over y. And the reason why I'm doing that is because I think it's going to be easier for you guys to conceptualize or understand what I'm doing here. So it's easy now to understand that x changes with respect to t, and y always changes with respect to something anyway. So in this case, it's changing with respect to t. Okay, so d, I'm finding the derivative now, because what I'm looking for is the derivative of x at the point that was given. They said how fast is x changing, so I'm looking for a derivative. X of t dt equals, this is 8 over y. The derivative, I think, am I missing something? No, I'm not. Okay, let me say 8y to the minus 1. The outside function here, the outside function is this guy, and the inside function is y, and they're both changing with respect to t, right? So I'm going to differentiate the outside function first. Don't mistake this for integration. Integration, this would be ln something. We'd have to go the ln direction. But this is differentiation. So differentiation of a simple polynomial like this, or not exactly polynomial, but something to an exponent, you just say negative 1, you bring it to the front, we have that 8 there, and you say y to the power of negative 2. You subtract the 1 from the exponent. This is how you differentiate this. Be careful not to mistake it with integration. Now we differentiate the inside function. That's going to be dy on dx, because the derivative of y, dt. The derivative of y with respect to t is just dy on dt. So we have dx of t on dt equals negative 8 over y squared dy on dt. Okay, this is what we have now. The derivative of x with respect to t is equal to this guy. They gave us the point, so we know the y value. They gave us the derivative of y at that point. It was negative 3. So we can substitute for this guy, we can substitute for this guy, and we can get our change in x with respect to t at that point, which we are going to substitute this side. Let's find it out. So dx on dt at what point? At x equals 4, right? The point was 4 is 2. That's equal to negative 8 over our y is 2, so that's 2 squared. And then our dy on dt, that was the rate, is negative 3. Important, the negative sign, because they said decreasing. A decreasing derivative, or I guess gradient of a tangent, is negative. Negative times a negative, that's a positive. This is a 4, so 8 divided by 4 is 2. So that's 2 times 3, which is 6. So our answer for this one is 6. Wait, what were we looking for again? Oh, how fast x is decreasing. Yeah, our answer is 6. 6. I'm going to try to do it another way. I think this is the easier way for you guys to understand, but I'm going to do the other way, and you guys are going to decide on what you want to try to understand. Pi equals 8 by x. You can first just do it straight up and say so say y prime equals negative 8 over x squared dx on dt. Okay, this is what I thought would be hard for you guys to understand, but if you understood this, it can be easier for you to go on to this. X is changing with respect to t, so you first differentiate this function as it is and you get this, and then differentiate x, the inside function, with respect to t, and you get this. Okay, this is also very easy to do. It's equally as easy as that. I just expanded the steps because I wanted you guys to see. But if you're using this, y prime is negative 3. That's the derivative, or the gradient, or the rate at that point, equals negative 8 over x. What's x at that point? 4. So you can put 4 squared, which is 16, dx on dt. That's what you're looking for. Okay, now you want to make dx on dt your subject. So let's first cancel out the 4's here. Actually, you just get 1 over 2 for this guy. The negative signs cancel out. This is 1 over 2. Multiply by the 2 to the other side, you get a 6, which is the same answer as the other side. So dx on dt equals a 6. You can do either way, and you should be fine. Good luck on your exams. Make sure to write your exams good, and text me on WhatsApp if you need the help. Shut up.